So our first presenter will be Robert Verco, CEO from Cobra Resources, talking about advancing scalable porphyry targets in the Nackara Arc.
Thank you. Hello. Lovely to be back again this year. Thank you to the SAEMC committee for all their hard work in keeping this fantastic conference going. Now, Cobra, we are UK listed, but very much South Australian focused. And our critical minerals portfolio is very much focused on energy transition minerals, particularly rare earths being dysprosium, terbium, and copper. Now, we have two exceptional projects in this state, and we're leaning into what we think are two significant benefits of this jurisdiction: in situ recovery. Our paleo channel hosted rare earth project at Boland over on the Eyre Peninsula has confined properties for hydrology that are enabling in situ recovery. We have industry-leading ionic desorption recoveries. We have amassed a significant land holding to control this opportunity on both the Narrabee and Yanini paleo systems. And we're growing in confidence that our cost of recovery, enabled by in situ recovery, can be very globally competitive. Going forwards for that asset, we're focused now on delivering scale and expect us to be doing a lot of drilling in early 2026. We've recently also exercised, or we have an option over the Manor Hill Copper Project in the Nackara Arc in an underexplored and forgotten porphyry province within this state. There are a number of targets, and what I'm going to talk to today is how a junior exploration company best is going to devise a strategy to deliver the next great copper discovery in this fantastic state that already hosts over 70% of Australia's copper reserves. Now, this project is really geologically interesting. The last hole drilled over 12 years ago intersected skarn mineralisation with an intersection of 48 metres at 2.2% copper and 0.76 grams gold from just 11 metres. It's a significant project with significant targets. Now, another great thing about this state is the work that GSSA do to promote and entice early exploration in this industry. In 2022, when land access was challenging within the Nackara Arc, we had GSSA have done a magnetotelluric survey across this geological terrain. Now, what this survey has shown is, like all the IOCG systems in the state, we have very deep crustal magmatic ponding within this region, and this is associated with the Anabama granite intrusion. So we think we have the right mid-level crustal big system geology to support large-scale discoveries. And the great thing about this jurisdiction is previous exploration has confirmed porphyry discoveries that are directly associated with that intrusion at multiple targets. Now, the challenge is we have a plethora of targets in this land package. We have some pretty enticing past exploration numbers. 132 metres at 0.5% copper from 8 metres is pretty enticing to go after. At Netley Hill, where we have porphyry mineralisation that's preferred by the academics, we have 350 metres at 0.1% copper and 0.05% moly from surface. So how are we going to utilise our funds to best deliver upside at this project? We have a 12-month option period to demonstrate to our investors that we can execute a strategy that delivers value, upside and scale. Now, what do we need to do to at best navigate those challenges? We need to understand what our exploration risk is. Going after porphyries is expensive work. We need to appreciate that the geology is complex. We're in the Adelaidean fold belt, and we've got overprinting structure that is controlling the intrusives, and we've got predating structure that is complicating the story. Our weathering is extensive, and do these systems are they preserved to a level where we'll discover economic mineralisation? But we think we can devise a very focused process to deliver upside and facilitate a significant porphyry discovery. Now, as we saw with the earlier talk with DiscoverCo, data is important in refining targets. Now, at Blue Rose, we think we have the right geological setting to facilitate that major porphyry discovery. We have fertility. We have a skarn unit that's mineralised for over 1.6 kilometres with some exceptional grades. We have a large geophysical bullseye anomaly that is a remnant magnetised feature that's indicating multiple phases of alteration. Spectrally, which I'll go into shortly, we have the indications of a broad porphyry system, and we have a geological age for intrusion here and alteration that is 480 to 460 million years, which is coeval to the Cadia porphyries of the Nackara Arc. Now, we're very fortunate, and I'll go back to that slide, to have had one deep diamond hole drilled into that intrusive geophysical bullseye anomaly. And that hole is in the core library, and we've done a lot of spectral work on the data sets and the drill holes that are available. And what that spectral work is showing is that that deep hole was very much a near-miss hole. It was drilled through the alterations and has just zones of a classic porphyry model and has just clipped the potassic zone. This gives us confidence that we have a preserved system under cover, and we're going to advance this strategy now where we focus on Blue Rose as our priority prospect, but we're going to do it in a very considered fashion. We can build up and vector in geochemically to locate that porphyry envelope mineralisation by utilising the skarns to build up that data set. Now, what we have here is we have a reinterpreted gravity picture, and this is detailing the existing skarn mineralisation. And in context to that, the circle is that remnant demagnetised feature. We've got some fantastic grades in this skarn, and we believe there is significant scale to be added. Now, please note here the gravity high on the inside of that skarn mineralisation. If we consider what that mineralisation looks in section, we have an broad oxide zone close to surface, and the mineralisation is contained in the footwall of a limestone unit that is strata bound within Adelaidean black shales. Now, think about the density of a black shale, which is probably about 2.2, and we compare that to a limestone at around 3. And when we assess that gravity data differently, and we look at where the largest discrete change in gravity occurs, we see a very interesting geological story start to take shape. We see that the greatest change in gravity correlates directly with that defined skarn mineralisation, and that unit is actually folded. What's that mean? Well, it means we have a second limb to chase, and we hope that this is a syncline and we have a fold hinge with greater structural deformation, improved fluid porosity as a primary target at depth. So what are we doing about this and how are we going about it? Now, some people may say that I'm still drawing male appendages on pictures, but you can't help the geology. Now, what we have here is our modelled intrusive and our modelled syncline, correlating to the defined mineralisation within that southern limb. We currently have a geophysics crew in the field executing a detailed IP survey that we hope will support this interpretation, and we're very excited to be the first explorers to be out drilling this target for the first time in over a decade. We expect to be drilling either later this month or early in January, where we'll be testing this model, aiming to demonstrate that scale and build up that geochemical data set. So next time I'm speaking here, we'll be talking about testing that porphyry at a much greater depth. Now, the great thing about this land package is there's no shortage of targets and interesting geology. Netley Hill is a fascinating, scalable target, and in a world where copper forecasts are very encouraging and mined grades are declining, this is a compelling, scalable target. We have multiple drill holes defining low-grade copper and high-grade moly from surface over an extensive footprint. And we think with a boots-on-the-ground strategy, mapping out those porphyry vein sets that we see in those core photos, at surface will help us vector in on greater densities and higher grades. So that's work in progress and something that we're very excited to be able to proceed with. Now, the great thing about porphyries is they also come with other unique and associated forms of mineralisation. Golden Sophia is a fascinating target that is a confirmed style of Carlin mineralisation. Now, this occurs proximal to the Wataminga goldfields that produced around 25,000 ounces historically. And we think by deploying an extensive regional soil survey across this, we can define structure. We do not think that this unit is strata bound, as previous explorers did when it was discovered. We think the structural control is very important for the permeation into the pearlites within this region. Now, I must mention that those intersections are from within 10 metres to surface. So we're talking about very shallow mineralisation, and we expect to see a very strong response in surface chemistry. So what's that mean? Well, we now have a very established team based in Adelaide, and across these targets within the next 12 months, we're expecting to do a lot of drilling. We are preparing ourselves in terms of land access and heritage clearance to have a free run to really execute intensive exploration over the next 6 months. This will see us deliver a resource at Boland, followed by a scoping study, and hopefully South Australia's next major copper discovery.